Hello and welcome. We are CLAWS, the Collaborative Lab for Advancing Work in Space. Our team of students from the University of Michigan works on developing new technologies for human space exploration. My name is Riley, and I'm the CLAWS team lead. I'm joined by Sahil, Emily, and Delenn, and we're so excited to be discussing some really great questions from K-12 students. We did some research ahead of time to make sure that we're giving accurate and up-to-date answers, as well as providing some helpful pictures along the way. Our team even learned some things. So, to take it away, Sahil will answer our first question.
Hi everyone, my name is Sahil, and I am the System Administrator for CLAWS. The first question that we have is actually from the CLAWS team itself, and that is, what is space? And the answer to this question is, well, everything. Everything you see around you is a part of space, but space is much larger than what we just see on our planet. To really look at how big space is, we have to look up, preferably at night. On a clear night in most suburban areas, if you look up, you might see a view similar to this. There's a good amount of stars. You can make out some constellations, such as the Big Dipper. I personally would be pretty happy if I went stargazing and saw views like this. But you might be asking, space doesn't look that big. There's like 50 stars, maybe 60 stars, who knows. But to answer that, we're going to have to drive a bit away from cities and light, and then look back up at the night sky, and we might see a view like this. Now that is a lot of stars. I have only seen stars like this once, and it's really indescribable how pretty it is. There are a lot of stars out there in space. But the best part of this is we can still do better than this. There are a few areas that are like reserved on Earth that have virtually no human-made light, and these are called dark sky communities. If you go there, you look up on the sky, and it's, let's say, like it's a new moon, so you can't really see any light from the moon, and you might see this. There are so many stars that we can't even begin to count them. Every single one of those light dots are little stars that are trillions of miles away from us. That really tells you how massive space is. Emily is going to talk about some of the other things you might find in space.
Hi everyone, my name is Emily and I'm the software lead for CLAWS. So that brings us to this photo. This is what we call the Hubble Ultra Deep Field. It was taken in 2014 over a long exposure of 11 days. And how this picture is different from all the other ones we've seen before is it reveals so much about the history of the galaxies that are in it and about the universe and how it develops. So there's about 3,000 galaxies that you can see in this image. And this was taken by the NASA Hubble Space Telescope. And now this thing was launched in 1990, and it is still operational in Earth's orbit, and it could last until 2030 or 2040. Now, fun fact, this actually is as large as a school bus and weighs as much as 2 adult elephants. So this is a lot bigger than what we would think. Now, to continue the question of what is space, we go to what is in space. So first we have planets. Now these come in lots of different sizes and compositions and colors, and some of them are made out of gas, some of them are made out of rock, and there's a very big variety. And what planets do is they orbit stars. And you can see on the bottom, this is Earth. This is our planet that we live and call home. You can see it has a lot of water, clouds, and land, all different things that help make life on Earth sustainable. We wouldn't really want to live on the giant rock planet behind it. So next we have stars. Stars are big spheres of burning energy. And what they do is they provide heat and they provide light to orbiting planets. Now you can see that this star is very yellow and looks very complex. But you can see in the background, every single one of these dots and every dot that we see in the night sky is actually a star because it's burning so hot that we can actually see it from Earth. Next, we have galaxies, and galaxies are a big collection of planets and stars all rotating within each other. They are massive in scale. Okay, next we have asteroids. Asteroids are rocks that are irregularly shaped, and they form in things called belts, such as the Kuiper Belt and the asteroid belt. And sometimes they find their ways around the solar system and can actually hit planets and moons. Which brings us to our next category. So moons are similar to planets, where they are composed of a lot of different materials. Some have ice, some are rocky, some are gaseous, and they are much, much smaller than planets, and they actually orbit planets. So our moon is a type of moon, and we can see that in the night sky when it reflects the light from our sun. And next we have man-made satellites or spacecraft. And so these are things that we send out into space to try to understand the universe we live in and take measurements and photographs of our solar system and different planets. So this spacecraft right here is called Cassini, and it studied Saturn's rings and moons in 2004 through 2017. This was created in collaboration with NASA, the United States Space Agency, as well as the Italian and European space agencies.
Hi, I'm Delenn, and the next question we received is from Oscar and Gable, who asked, "Are aliens real?" The answer to this question is, we don't know. And when you think about it, there are lots of homes that are available for aliens. Just in the Milky Way galaxy, there are 250 billion stars, lots of which have planets of their own. And there are 100 to 200 billion galaxies in the universe. So putting this all into perspective, there are a lot of planets on which extraterrestrial life could exist. But first, let's take a step back and look at what makes up life and what we need to survive. We need to understand what is necessary for life to exist as we know it, so we know what to look for in our search for extraterrestrial life. From our current understanding, there are certain building blocks that are required for all life, the first of which is liquid water. Liquid water is essential to living organisms, and put simply, has many physicochemical properties that make it an ideal ingredient for life. We also need an energy source, or food. We need a source of energy to power the biochemical reactions that occur in our bodies on a day-to-day basis that allow us to function normally. All life as we know it is also carbon-based, and this doesn't mean it necessarily has to be that way on, say, another planet, but carbon is a very likely candidate for the basis of extraterrestrial life as well, because it can make a wide variety of different types of bonds with other atoms and molecules, and allows very complex molecules to form that we need. And the next best bet would be silicon, because it is the element right under carbon in the periodic table, so it can also make 4 bonds. But the problem with silicon is, unlike carbon when combined with oxygen creates CO2, which is a gas, silicon combined with oxygen creates silica, which is a solid, and that might cause some issues. We can also look at the range of conditions under which life can exist on Earth itself to see under what conditions life might be able to exist on other planets as well. For example, on Earth there are organisms called extremophiles that live in very extreme environments, such as in underwater hydrothermal vents, where they are subject to very high pressures and temperatures but are still able to survive. And these conditions under which they live might seem very extreme from our human perspective, but not necessarily for them. It's normal for them. And so these extremophiles can give us insight into what range of conditions life is possible. And one example of extremophiles are tardigrades, also known as water bears. They're usually less than 1 millimeter in length, have 8 legs, are almost cute, and are nearly indestructible. They can live in some of the harshest environments on Earth and even live in space. They can withstand extreme cold and heat and survive lethal doses of radiation. And they are able to do this by undergoing a transformation called cryptobiosis, or a tun state, and where, kind of like roly-polies, they curl up into a ball, and it's an almost death-like state, and they majorly lower their metabolism, but when they are reintroduced to water, they uncurl and go back to living their normal lives. And these tardigrades and other extremophiles are amazing because they push the boundaries for what we think is possible for life. We can also look at how life may have formed on Earth itself. Two scientists devised an experiment called the Miller-Urey experiment, where they created a closed system and took a mixture of gases that mirrored the early Earth's chemical environment and put them in the system. And then they used electrical discharges to simulate lightning, which provided energy for reactions to occur. And they found that amino acids were spontaneously produced. And this is very important because amino acids are the building blocks for life. And so this experiment showed a possibility of how life could have formed on Earth. Taking all this knowledge into consideration of what makes up life and where we think life might be able to exist, we can see where we think life could exist around a star. And this range or zone, called the habitable zone or Goldilocks zone, here shown in green, is where we think life could exist around a star. Anywhere closer to a star is too hot, and any farther away is too cold. So in this perfect Goldilocks zone is where liquid water could exist, and also maybe life too. Humans have actually tried to contact aliens on multiple instances. For example, on the Pioneer 10 spacecraft, which was the first mission to fly to the outer planets, there was a plaque included on it called the Pioneer Plaque, and this plaque detailed the location of Earth in relation to different pulsars and also showed what we humans look like. So in the off chance that extraterrestrial life were to encounter the Pioneer 10 spacecraft and find the plaque, they might be able to contact us. Similarly, on the Voyager 1 and 2 probes, which have both entered interstellar space, and currently Voyager 1 is the most distant human-made object in space. Both of these probes contain a golden record, which is a phonograph record that contains the sounds and images meant to portray the diversity of life and culture on Earth. Scientists have also tried to predict the likelihood that we might be able to contact other civilizations. For example, astrophysicist Dr. Frank Drake, while he was working as a radio astronomer at the National Radio Astronomy Observatory in Green Bank, West Virginia, devised an equation, now called the Drake equation, that estimated the number of technologically advanced civilizations in the Milky Way galaxy that we might be able to contact. And while this equation is very speculative and there's no definitive answer that can come out of it, it gives us an idea of how many civilizations we could possibly contact. And it takes into consideration terms such as the rate of formation of stars in the Milky Way galaxy and those that have planetary systems that have an environment suitable for life, and out of those systems, which have suitable planets where life could appear, especially intelligent life that could release detectable electromagnetic signals. And there's one more term called the longevity term, which is the length of time that a civilization could send out these electromagnetic signals that we could detect. And this is arguably one of the more important terms. So overall, we don't know if aliens exist. They could be out there and we just haven't contacted them yet, and hopefully we will find out soon.
Alright, our next question. Will NASA start making rockets for the military? The answer to that is they already have. The Jet Propulsion Lab, or JPL, is a NASA facility that was originally founded by a group of Caltech students as a place to experiment with rockets safely. They used to just launch rockets wherever they felt was a safe enough area, a little bit away from people, and that was really dangerous, but their work was also really impressive, so Caltech made sure that there was actually a place that they could go, and other people that were interested in rocketry could actually go and launch and test rockets. So that's how JPL came about, and it wasn't actually a NASA facility back then. It worked with the Army to design rockets, such as the MGM rocket you see over there. It wasn't until the late 1950s that JPL actually got transferred to NASA and started working on these space exploration missions. So NASA facilities have already designed rockets for the military.
Hi, it's Riley again. Our next question is from Jacob and Morgan, who ask, have you ever seen a meteor up close? Well, to start, let's first answer the question, what is a meteor? If you look at the chart on the left, we have some helpful images for this explanation. At the top, you see a comet. A comet is a big chunk of ice and rock that comes from the edges of our solar system. The next one down is an asteroid, which Emily talked about earlier. In our solar system, we have what we call the asteroid belt. This belt is a bunch of very large space rocks that make up a ring around the sun and sits between Mars and Jupiter. Sometimes asteroids can get knocked towards Earth. A meteoroid is a small chunk off of a comet or an asteroid. When these meteoroids enter Earth's atmosphere, they start to burn up, and we call these meteors. You may have heard of meteor showers, which happen when there are a bunch of meteors falling towards Earth. These look like the picture on the right. Finally, if a meteor doesn't entirely burn up in Earth's atmosphere, what hits the Earth is called a meteorite. So, if we go back to the original question, have you ever seen a meteor up close before? Technically, the closest that you could ever see a meteor from is while you're standing on Earth and the meteor is falling towards Earth in our atmosphere. So I have not seen a meteor in the sky before, but if you'd like to see one, there's a way you can do that. If you check out the American Meteor Society online, they release a bunch of information about how you can spot meteors and where's the best places to see them from. They also release a calendar showing you, if for your location, when the next meteor shower is going to be. So I would check that out if you're interested. That said, if you'd like to see a meteorite, which is the remaining rock that survives the fall through our atmosphere, many natural history museums have meteorites on display. For example, the Willamette meteor shown here is the largest meteor ever found in the US, and it's on display at the American Museum of Natural History in New York City.
The next question we received is from Jacob and Morgan, who asked, what is the longest time that someone has lived in space? There are several different time and space related records, but let's first start with the longest consecutive time anyone has spent in space. This record is held by Valery Polyakov, a Russian cosmonaut who spent a total of 438 consecutive days in space, where he worked on the Mir space station. Another record is the longest total time that has been spent in space, which is held by Russian cosmonaut Gennady Padalka, with a total of 878 days, so not necessarily consecutively. And he's worked on both the Mir space station and the ISS. Now for US records. The longest time any US astronaut has spent in space consecutively is Scott Kelly, where he spent 340 consecutive days on the ISS. And he's also written a book called Endurance about his experience in space and the long-term effects of spaceflight on both the body and the mind, and you should check out this book. The next US record is held by Peggy Whitson for the longest total time spent in space by any US astronaut, at a total of 665 days, where she also worked on the ISS. One more record is for the longest consecutive time in space by a woman globally, and this record is set at 328 consecutive days by Christina Cook, who spent her time working on the ISS.
So for our last and final question today, we have, when do you think the first person will go to Mars? So this is such an exciting question for all of us on call, because we love Mars and we cannot wait until we land the first people on the Mars surface. So to first put it into context, we have to go to the moon first. Now this is a strategic choice because if we send people to Mars, we won't have the technology to keep people safe when they're there, or even travel there in a reasonable time with efficient technology. So the goal that has been proposed through the Artemis program is we will send people back to the moon, because the last time we landed on the moon was quite a while ago, and we will land there in 2024, landing the first woman and the next man. And this is called Artemis 3. And after that, after we've established a presence on the moon, we will continue on to go to Mars. Now, our estimate is that we will reach there by the 2030s, but a lot of things in space take a long time and the timelines are flexible. So this could definitely be later, but that's when we think that we'll actually reach Mars. We've been to Mars before with rovers and probes, but we are very excited about having people live there for at least a temporary period of time. So we want to talk about a few other facts that are related to this topic. So the first is just a great book that we all love called The Martian by Andy Weir. And this talks a lot about the technology that can be used to sustain people on Mars. And it's set in 2035. So I would say a reasonable timeline for when the book would take place. And it follows an astronaut who gets trapped on Mars. And it's very, very interesting. Next, we have the NASA SLS rocket. So SLS stands for Space Launch System. So this rocket is going to actually bring people to the moon in 2024 through the Artemis program. And then the last photo is the SpaceX Starship. So this is a spacecraft in development by a private company called SpaceX to be a fully reusable spaceship for carrying people and supplies to the moon and to Mars. SpaceX is just one of the many private companies that are getting involved in human spaceflight. We just wanted to say thank you so much for tuning in. We hope that you got a lot of information out of this, but if there's anything that you would have liked us to include or anything that you would like us to answer in the future, or just general feedback, please contact us. Our organization focuses on software use in space, but we're all pretty big space nerds, and we're very happy to do something like this for, everybody, the general community. Thanks again.